All right, we're going to start by looking at numbers 29 to 32. All right, 29. Somebody read 29 for me, please. Seth.
As an x, as the approach to -6 of x.
All right, so say it from the beginning again.
Eliminating x as an approach to -6 of x.
You're close. Faith, I'm asking, how do you read 29?
Limit as x approaches -6 of f of x.
Very good. So that's what we're looking for. And our number one takeaway from Friday should have been what?
Looking for a y.
Limit. The solution to a limit is a y value. Very good. So on 29, as I'm approaching the x value of -6 on the graph of f, what is my limit? What do you think? Speak up. 4. Anybody have any issues seeing 4? You need to speak up if you can't see that the limit as x approaches -6 of f of x is 4. -6 is right here. So what y value is my graph doing, or going to, as I get closer and closer to that? So as I come in here, as I come in there, what y value is pinched in there?
So the limit is like how high, like where it's
The limit is the y value.
where it meets. And
Where, when I come in from the left and from the right, where those two things meet, that's that y value where they meet, that is my limit. So in this case, they are meeting at the y value 4, so my limit is going to be 4. All right, 31. Alexander, read 31 to me.
Limit G. I'm not really sure.
Garrett, how do I read that?
31.
Yes,
Limit as x approaches 4 of g.
very good. The limit as x approaches 4 of g of x. And what do you think on this one?
Doesn't exist
Does not exist is correct. Why, Austin?
because it's an asymptote.
There's an asymptote there, so should be able to tell that there's an asymptote here. And what is both sides of that asymptote doing? Where's it going? Both of them are going to infinity. Now, why is it does not exist instead of infinity? Somebody adds, because they're both going to infinity, why can I not say infinity instead of does not exist? Because infinity is not a number. And the solution to a limit is a y value. Infinity is not an actual value, so therefore it does not exist. Now, they liked for us to go ahead and say that it's headed to infinity, though. So I want you to say D and E, and then I want you to say headed to infinity. That way, you know that as you get closer and closer to the x value of 4, your graph is headed towards infinity. Yes.
If you go in opposite directions.
We'll get there in just a second. Okay? 30. Kinsey, read 30.
the limit as x approaches 4 of f of x.
Very good. And what is that limit? There are usually 3 answers on this one that people want to say. What's one of those 3?
No, it's -6.
-6 is 1. Does anybody want to give me another answer? 2 is another one. And does anybody want to give me one more? Does not exist. Those are usually the 3 answers that I hear on this problem. Which one of those is correct?
-6.
-6 is correct. Very good.
So I got the correct
You
one?
got it correct.
I don't.
Why is -6 the solution? Because all that matters when I'm doing a limit is what?
Where they meet.
Where are we going to meet as I come in from the left and from the right? So 4 is where I'm headed. As I come in from the left, as I come in from the right, where are we meeting up at? The y value of -6. Now, some of us get thrown because of that dot right up there. It does not matter what's going on at the actual x value of 4. All that matters is what? Where am I going to meet up? If I were to meet up, where would I meet up at? It doesn't matter where the actual point is at. All that matters is where am I going to meet up. Okay? And as I come in from the left, as I come in from the right, I'm meeting up down here at this spot, which is -6. So that's why my solution is -6. Okay? Do not get distracted by what's going on everywhere else. All that matters is what's happening as I meet up at that x value. Okay, where am I meeting up? All right, 32. Okay, let's read 32.
Limit as x approaches -6 of g.
Okay, limit as x approaches -6 of g of x. -6 is right here. So what do we have again? An asymptote. So what does that mean my limit is?
D.
It's D and E. Okay, but what's different about this one versus the first one? The left side is going where? Up to infinity. The right side is going down to infinity. Are they going to the same place? No. Then I cannot add this little extra piece that I did the first one. Okay, I just have to say D and E and stop. Okay, if you say D and E, that tells me that we are not headed to the same place. Okay, if you tell me D and E and then headed to infinity, that means the limit doesn't exist, but I'm still headed to the same place, and that is infinity. Yes.
Listen, D, any on the bottom, right? DW?
D and E. You want me to do that to your handwriting?
D.
You guys are a lot worse than mine.
I think your handwriting is perfect.
All right. Next type of problem. Jump up to 33.
It's gonna be difficult. It'll be like your phone.
33. We want the limit as x approaches -4 of -17 divided by x squared plus 8x plus 16. So what do we want to do to attack this?
Plug it in.
Write it
We
down.
want to graph it. So I'm going to go graph it. New document. We're not going to save it. I got a graph. Control divide. I had -17 on the top. What was on the bottom? X squared.
Plus 8x.
16.
Enter. All right. So that's what I'm looking at. What do you guys think? Where am I supposed to be headed?
-4.
-4. Now, what's something I can do to maybe get a better idea of what's going on at -4?
Zoom out.
All right, and well, I don't want to zoom. Let's control the window a little bit better. So let's go to menu. Let's go to window zoom, and let's go to window settings. What do you think I want to adjust my X min and X max to if I'm wanting to approach -4?
5.
-5 and -3 sounds good to me. So let's do that. Let's make it, we're going to go from -5 and we're going to go -3. So where is -4 going to be located when I press enter? Exactly in the middle. So I press enter. I can't see it. If you can't see it, then you go menu, window zoom, and then we're going to go zoom fit. That should bring it into play. So now you got a better idea. So my graph is here. My graph is there. What's going on right smack dab in the middle? There is an asymptote. So what is the answer to my limit going to be?
D and E.
D and E.
Headed to -infinity.
Headed to -infinity. So let's verify that. Let's see if you guys do better with your numbers this time. Now that you have my trick. Where are the 0.9s going to be and why?
On the right side.
On the right side. Why?
Because it's headed to 0.
That's where zero is at. So -3.999, -3.99, -3.9. -4.001, -4.01, -4.1, So control doc, calculator, variable, enter, negative 4.1. Enter, variable, enter, negative 4.01, and so on. Okay, and this is exactly what I was talking about earlier. Alright, as I move in from the left, as I move in from the right, it looks like it might be going to negative 17 million, correct? But what did I tell you earlier that tells you that there is not a limit?
Because the Y's are too far apart.
My y values are not close. These y values are not close to each other. Even though it looks like they're going to the same number, if my y values are not close, that tells me it's D and E. Okay? So this is D and E, but my y values keep going down, so that means I can go ahead and say it's headed to negative infinity. Okay? Bless you.
Bless you.
Thank you.
Alright, next one. Alright, let's look at 35. Limit as x approaches 4 of the absolute value of x over x minus 4. Go home, new document, no, I want a new graph, control divide. What was in the numerator?
Absolute value.
Absolute value of x, and the denominator? X minus 4. Press enter. There it is. What does it look like might be going on at 4?
It's in the same thing.
Looks like there's an asymptote at 4. Okay, so that means it would be D and E. Can I say it's headed anywhere?
No.
No. So, let's make our chart. 4 is in the middle. Where are the 0.9s going to be?
On the left.
Why?
Because it's going towards 0.
That's where 0 is at. Good. So 3.999, 3.99, 3.9. 4.001, 4.01, 4.1. Control doc, calculator, variable, enter, 3.9, and so on. Oops. So negative 39, negative 399, negative 3,999, 4,001, 401, and 41. So as I come in from the left, as I come in from the right, am I going to the same place?
Yes.
No. And what is the dead giveaway that there is not a limit?
The Y's are so far apart.
My y values are too far apart. That tells me there is not a limit. So then I need to decide, am I going to the same place? Are we going to the same place? No, because the left side's going where? Negative, and the right side's going positive. They're going two different places, so that means all I can say is does not exist. Okay? Now, as you saw the other day, you might see a little plus up there. Okay? That plus means what is my limit from just the right side only. So I would still say does not exist, but this time I could say what?
Headed to infinity.
Headed to infinity. Okay? You also might see a 4 with a minus, which means left. So in this case, I would still say D and E, but this time I could say headed to negative infinity. So that's what that little plus and the minus means. They only want one side or the other. All right, 41. 2 more. 41 and 43, we're done. 41, 3x minus 4 over 9x plus 3. So home, new document, no, calculator, control divide. What was on the top?
3x minus 4
Bottom was 9x
plus 3.
plus 3. Enter. Okay, but where am I going this time?
Infinity.
I'm going to infinity. So on my graph, where does that mean I'm going?
Up.
I'm going to the right. Very good. Because remember, where I'm going is what type of value?
X.
An x value. So if I'm going to infinity, that means I'm going way out there to the right. Okay, and again, when I'm looking for an answer, a solution to a limit, what type of value am I looking for? Y value. So as I head to infinity, is there a y value that I'm headed towards? Okay. In this case, what do you guys think?
No.
I'm hearing some no's, but there actually is a y value.
It'll
Because
level
won't it
out
eventually
somewhere.
cross the y-axis?
What do you guys see on this graph?
It levels out.
1/2.
What is on this graph that we haven't talked about earlier? There's a horizontal asymptote. Okay, there's a horizontal asymptote right there. So what value, just as an estimate, it's got to be between what and what?
1 and 0.
0 and 1. It's got to be between 0 and 1. Okay, so when you're going to negative infinity or infinity, we're talking about the horizontal asymptote. The horizontal asymptote tells me where I'm going. Okay? So, infinity. What numbers do I plug in if I'm going to infinity?
Whatever numbers you want.
Numbers that get progressively larger. So let's do 10. Let's do 100. Let's do 1,000. Let's do 10,000. Okay, and let's plug those in. So I do control, doc, add a calculator, variable, enter. Now, what is not on these numbers I'm plugging in that has been on the numbers that I've been plugging in?
Decimals.
Decimals. Make sure you put a decimal on there. What will the decimal do for me when I put it on there?
It'll give you decimal.
It'll give me a decimal. If I don't do that, it's going to give me a fraction. So make sure you put a decimal on the end of it. So I plug in 10. I plug in 100. And so on. Oops, I forgot my decimal. See what happens? Make sure you put that decimal in there. Alright, so let's write down what we got. So 10 gave me 0.279, 100 gave me 0.327, 1,000 gave me 0.332, and then I have 0.333. So as I head this direction, what number does it look like I'm going to level off at? 1/3. So my limit is going to be 1/3. Now, if I go back to that graph, let's remember how, just by looking at this right here, 3x minus 4 over 9x plus 3, how did I know my limit was going to be 1/3?
Coefficients.
Very good. If you remember, if you're doing horizontal asymptote, you want to look at the highest exponent of the numerator and the denominator. In this case, they are the same. When they are the same, your horizontal asymptote is going to be the coefficient. So 3 over 9, which reduces to 1 over 3. Caleb, what happens if my exponent in the denominator is bigger than the one on the top? Tanner, you remember? Peyton?
What is the question?
If the exponent in the bottom is bigger than the exponent in the top, what is my horizontal asymptote?
You subtract them. Either 1 or 0.
0. If the bottom exponent is bigger than the top, my horizontal asymptote is 0. If the top is bigger than the bottom, there isn't a horizontal asymptote. So if they're the same, I take the coefficients. If the bottom's bigger, it's 0. If the top's bigger, there is not one. Alright, one more. So I go home, new document, no, we want a new graph, and we're looking at 43. 43. 3 to the x plus 3 to the negative x. So you guys are going to have to help me on this. Control divide. 3 to the x, is it plus?
Yes.
3 to the negative x?
Yes.
Over 3 to the x minus 3 to the negative x? Press enter. Okay, and where are we headed on this one? Where did it say we were headed?
Negative.
We're headed to negative infinity. So what does it look like just from the graph? Negative 1. Looks like we're going to negative 1. Okay. As I move to the left, it looks like it's leveling out at negative 1. So since I'm going to negative infinity, what numbers do I want to plug in?
Negative 10.
Negative 10, negative 100, negative 1,000, negative 10,000. So let's see what it does. Let's see if it verifies. So control dot, calculator, variable, enter, negative 10. Don't forget your decimal. Variable, enter, negative 100. Okay, whoops, I forgot my decimal again. Okay. So, does it verify? Yes, because we've got negative 1.000, then it just gives me negative 1, negative 1. So that verifies my limit as I go to negative infinity is negative 1. What about as I go to infinity? Positive 1. Okay. So the limits as you go to negative infinity and positive infinity can be different. Alright, so that's it for today. Alright, what is a limit? A y value. What has to happen in order to get a limit? What must happen in order to have a limit?
Where the lines meet.
My lines, yes. As I come in from the left and the right, I have to be headed to the same spot. If I'm not headed to the same spot, I do not have a limit. Does that spot have to be there?
No.
Can it be somewhere else?
Yeah.
Yes. All that matters is that I'm pinching the same spot. And whatever that y value is, that's my limit. If I'm approaching an asymptote, what will my limit always be? D and E. When can I say it's headed to infinity or negative infinity? As if they're going the same direction. Okay? And if you're doing the limit as x approaches 3 and it has a plus on it, what is it asking for? The right side and a negative? Left side. Good.